Measures of central tendency. Say you have retail stores in India, US and UK. Say you have retail stores in these three nations. The very first question which any management person would ask you is, on an average, what are our sales? On an average, what are our profits? On an average, how many employees do we have? On an average, how much discount do we provide? So this would be the very first question which any management person would ask. Hence, measures of central tendency is given a name, first moment business decision. First moment business decision. Yeah. And as I've told you, population parameters are always represented using Greek letters as opposed to sample statistics. Yeah. So we'll discuss these using the Excel sheet. Where did that go? Sorry, my man. Yeah, here we are. So we are discussing about measures of central tendency, which is also called as first moment business decision. So I wish to hide everything else and explain only about this data set. So just bear with me. Okay. Let me also hide these. Say there is a simple data set wherein we have 5 data points, 1, 2, 3, 4 and 5. We need to calculate the mean or average of the data set. How do we do that? Formula is simple. Please pay attention here because every now and then we need to, revisit this formula. So the formula is as follows. It is summation of I equal to 1 until n, xi divided by n. This xi here is a random variable. Okay. Now if I substitute I equal to 1, you would have a small notation because capital X is a random variable, small x are the values which this capital X can take. So I equal to 1 is x1 plus I equal to 2 would be x2 plus I equal to 3 x3 plus x4 plus x5. Why do I stop at x5? Because you have only 5 numbers there. Divided by n, n is the number of data points, you have 5 data points. x1 is 1, x2, x3, x4 and x5. So it's 1 plus 2 plus 3 plus 4 plus 5 divided by 5, which is 15 by 5, which is 3. Right? This is how we need to calculate the average. Let me also use the Excel formula, which is nothing but average. I select all these numbers and I get 3. Now I need to unhide. Sorry, my bad. Let me unhide everything otherwise. That's okay. Yeah. Look at the scenario 2, dataset B. I'm taking the same 5 numbers, but I'm changing only one number. Instead of 5, I'm replacing it with 700. Now if I calculate the average, of all these 5 numbers, I get 142. Oh my God, there is such a huge difference. Just because I've changed only a single number, average moved to a different direction altogether. It has moved from 3 to 142. And these kind of extreme values, which influence your average to a great extent, are called as outliers. So mean is being influenced by outliers. I'll give you a small example of an MBA college. Hopefully I have the data here. Let me see. No, it's not there. Say you want to join a B school to do your MBA. The first thing that you would focus on is return on investment. Yeah, what are the salaries that the students from these B schools are getting, right? Say there is a B school which publishes that our students get on an average 30 lakhs per annum. You'd be tempted. You'd be tempted and you'll say that, okay, let me join this. But in reality, there might be students who might get 6 lakhs per annum. There might be students who get 8 lakhs per annum. There might be students, again, there might be another student who might get probably 6 lakhs per annum. And there might be one student who might be getting 1 crore per annum. Yeah. So now if I look into the average, look at that. If I calculate the average of all these numbers, I get 30 lakhs per annum. Only one student is getting 1 crore per annum. Rest of the people are getting 8 lakhs, 6 lakhs per annum. Until and unless you see this underlying data, it is very confusing for you. You assume that you will also be getting 30 lakhs per annum, right? Hence, please do not go with average when you have outliers. You need to do a thorough analysis. Yeah. All right. If there's a problem with mean, and if the mean is influenced by outliers, what is another best measure? Another best measure here is median. By definition, median is the middlemost value of a data set. Here, 1, 2, 3, 4, 5, the middlemost value is 3. And in dataset B also, the middlemost number is 3. Yeah. Now if I choose a different dataset altogether, dataset C, and if I provide this, if you go with this definition that median is the middlemost value of the dataset, you might be tempted to say that 700 is a median. But remember, median is not influenced by outliers. So what is going wrong here? You have to first sequence the numbers in an order. 1, 2, 3, 4 and 700. First sort these numbers in a sequence, either in an ascending order or descending order. And post which you pick the middlemost value, which happens to be 3. Now let me give you an example of another dataset called D. Here I have numbers 1, 2, 3, 4, 5 and 6. You do not have a single value which is the middlemost value, right? You have two numbers which are the middlemost values here. So if you have two numbers, then you simply take an average of these two numbers. If you take an average, it is 3 plus 4 by 2, which happens to be 3.5, and this is your median. This is how you need to calculate median. All right, this is fine. Now let me show you another dataset called E. Say there is a survey conducted, and the people targeted husbands, right? They went and asked the married people, husbands basically, on whether their wives beat them or not. First person says, yes, my wife beats me. Second person says the same. Third and fourth person, these two people are scared of their wife, so they say, no, she does not beat, right? And let me remove these 3. Yeah. Given this scenario, can we calculate mean or median for this data set? You cannot, for this kind of categorical or non-numerical data, we cannot calculate mean or average. So mean or average is not applicable. Median also cannot be calculated. So there is only one new measure that is applicable in this scenario when you have non-numerical data, and that specific measure is called as mode. Mode is a value which repeats itself maximum times. And given this data set, beat repeats itself 3 times. Yep. As opposed to does not beat, which gets repeated only twice. So in comparison to beat and does not beat, beat has repeated itself 3 times, maximum times. Hence that is your mode. If you have a single mode, it is called as unimodal. Yep. Now say you have interviewed 3 more people. One person is really scared, so he says neutral, I don't know whether my wife beats me or not. Another person follows the sweet, and another person says no, my wife does not beat me. Alright. Given this kind of a data set, if you were to calculate the mode, you see that the word or value beat repeats itself 3 times, and does not beat also repeats itself 3 times. Neutral is 2 times, but going by the definition, we need to choose that value which repeats maximum times. Since you have 2 values which are getting repeated 3 times each, you have 2 modes. One is beat, another is does not beat. And if you have 2 modes, it is called as bimodal. And if you have greater than 2 modes, it is called as multimodal. For now, just remember this diagram. For now, just remember this. If you have only one peak, this is how your probability distribution would appear like. For now, just don't worry about anything else. Just focus on this. If you have one peak, it is called as unimodal. If you have 2 modes in that way, it is called as bimodal. And if you have greater than 3 modes, it is called as multimodal. 3 peaks, 3 measures of central tendency. Yeah. It could be mean, median, or mode, but there will be only one peak. All right. This is the explanation pertaining to mean, median, and mode. But we are not done yet with this concept. Look at this image. There are 2 friends who went to jungle for hunting, okay, and they saw a lion. One person shot an arrow which has gone like that from the left side of the lion. Another person shot an arrow and it has not hit the lion, but it missed by a whisker and it went towards the right direction. Both of these people jumped with joy. They clapped hands. They hugged each other. Why? If you're wondering, let me tell you this. If the weight of one person is say 120 kgs, weight of another person is 60 kgs, what do you infer? Fully grown individuals, right? 6 feet high. 120 kgs weight is overweight. And 60 kgs is underweight. But if I take an average, what would I get? It'll be 180 by 2, which is 90 kgs, which is kind of decent. Right? So this is okay. This is normal. These 2 are abnormal scenarios. On similar lines, one arrow went from the left, another arrow went from the right. So on an average, they assume that it hit the lion and they started jumping with joy. Hence, we have to be very careful with statisticians, especially when you try to go to jungle. All right. This is just a funny example that I wanted to bring. And give a serious thought to this. Every American should have above average income, and my administration is going to see they get it. This was quoted by a famous American president a few years back. How can you have all the values above average income? If you have numbers 1, 2, 3, 4, 5, if you take an average, it is summation of all these numbers 15 by 5, which is 3. You'll have a few numbers which are below your average. You'll have a few numbers above the average. How can you have everyone having above average income? Is that possible? Give a thought.